is happening right now. Okay, so today we'll switch gear by talking. Well, actually, we mentioned a little bit about parallel programming, right? But before we go dive deeper into that, I will basically switch gear and motivate you guys from switching from one language to another, right? And we're diving into this language called Rust. Anyone hear about this language before? Anyone here heard about a company called Mozilla? I think you all heard about it, right? They have Firefox. So they actually have a branch that do programming language, and they actually invented, oh, again, the thing they kind of come up with, the engineer and invented Rust, which is one of the language that if you look at the theoretical side of things, it's actually really neat. And the performance side of things is also really neat as well, right? So we'll actually look deeper into this. If you want to learn new languages, this is one of the language I would say I recommend you taking a look at. The other few other languages would be like Golang, for example, the Google Go language, right? Those are another really useful language to get to know. Many new, at least like a research type database system are now being basically written in Go more often these days, right? So these are some of the interesting things that uh, evolving. Scala is another really evolving languages as well. Whatever you learn so far, it's going to be hopefully useful going forward. Uh, and actually, let's do a quick recap when we conclude the class from. Oh my God, my arm hurts. Sorry, I was trying to raise my left arm, and that's where I got the shot. But now I can't go like above this level. So, uh, so let's do a quick recap on the concurrent plus asynchronous program, right? So what does it, we kind of cover what does it mean for a program or one single program to have concurrency, right? We also cover what does it mean for something to be asynchronous. If you kind of have the question, okay, what does it mean to have things, what does concurrency mean in human language? Can someone tell me or define what does concurrency mean? Yeah, to be able to do two more than two things at once, right? The ability to be able to run more than one thing or execute more than one thing. Why are they good? Why are they good? You can do multiple things at the same time. Typically, that means your performance improves. Sometimes if you heard about throughput, right? Is one of the way you can kind of relate to performance. It's not directly the same as like execution time, but more throughputs means that you can compute more thing per a unit of time, which is another really useful metric as well, right? It's the same as you have bigger pipe, right? Because let's say you have a pipe system where you want to have water flowing from one side to the other, right? If you have a pipe with like 1 inches diameter, it's gonna be able to like basically put water through with the same speed. Less water will be coming out if you comparing that to another pipe system that have the water flowing through the same speed, but with 2 diameter for the pipe, right? And that's the measure of throughput. And functional programming, the model itself fits really well with both concurrent and asynchronous program, to be honest, right? Asynchronous programs basically means that if you need to wait for something until you can resume and go forward with your execution, you can switch and do something else. Don't stall, right? Basically, don't stall. Try to find something else to do in the meantime, which is typically a good idea, right? Uh, how many of you, let's say you download, like you install Steam, right? And you bought a new game. And while you're downloading that game, you are basically like watching YouTube and doing something on the side so that it can be, the things can be downloaded while you're doing something else. And that are fun, right? So we do that all the time. This is, to be honest, think of it the same way. It's like the same analogy. And this kind of map well with multi-core, right? Why is this mapping well with multi-core? So the benefit of having multiple things at the same time get pronounced, right? It's actually really obvious when you can do multiple things on a multi-core processor because you actually have the processor to do it, right? Remember the single core processor like Pentium 4, and you compare that performance with a slower clock, but newer generation that has multiple core, and likely that you will you actually likely to buy the multi-core one, right? Because that's the nature of what you use computer for. In many cases, like your desktop are likely to contain multiple programs running at the same time, right? So you can take the advantage of this multi-core processor, right? So with that, right, I want to dive deeper into kind of like an intro to parallel programming by looking at both system and parallel programming. For those of you who take ComSys Arc or OS before, anyone here took that like OS or ComSys Arc before? Can you raise your hand? Or are you still waiting to take that class? I'm not sure. Maybe I should ask this earlier. Uh, they're, they are typically hard. That's how I should put it, right? If you're taking the OS class, system programming has a lot of problem. Uh, Many of them comes with the fact that you can actually have multiple tasks that the OS, like Windows, Linux, has to run, right? It's not like you boot up a computer and the only thing you do at that time is like use Microsoft Word. Typically, you would be, for example, listening to a radio, listening to some music like Spotify, right? In the background while you're working, you do multiple stuff at the same time. It does mean that the system side of things has to figure out, okay, when do I run this? When do I run that? You actually need something to run your program, and that thing is your CPU, right? The other problem is handle secure. Like you want to make sure the program you're running on Chrome cannot look into whatever you're running on Microsoft Word or Adobe PDF, right? It just basically breaks the security assumption. So system programming basically ensure that those two things have to be secure and fast. Parallel program also have something similar, but not exactly the same. It's hard to debug, right? We kind of motivate this problem earlier. Let's say you run a program in parallel. You can run it on 4 cores. You don't know which one are gonna finish first. It can happen that if you run in this exact order, your program is fine. But if you somehow run it in a slightly different order, you run into bugs. That means that you run this program 100 different times. Sometimes you see bugs, sometimes you does not. You do not, my bad, right? So when you do not see any bugs, it means that, oh, I'm screwed. I need to rerun it again until I find a bug and debug it, right? That can be a problematic thing. So let's actually talk about Rust and how Rust as a language try to address, to be honest, address this problem, right? And some of the code example here and going forward, right, will be based on Rust. So the first thing we have to learn right now is to read the program and know how the language works, right? So let's introduce the unique thing about Rust. The first thing, so right now we are into the topic of Rust 101. Right, the first thing that Rust provide what we call type safety, right? What is a type? Anyone remember? Okay, now that we're actually talking about exam coming up, what's a type? Can someone define what does type mean? We covered this last week, I think. Well, if I tie a data to a type or an expression to a type, what does it mean? What does it hinting the program? It's hinting that eventually it will evaluate to that type as perfect, if there's a perfect definition. Basically, in Rust, your program is well defined, right? You don't have any weird undefined behavior on all cases of execution, unless unless you actually declare the code unsafe. You can do that in Rust. We are not going to do it for the purpose of this class. You can do it for your project. You can declare your code unsafe if you know exactly what you're doing, and Rust will relax this type safety. But by default, right, it's going to be a type safe language. You have a well-defined program, it's a type-safe language, which means that every single line of your program is going to be well-defined, right? So my question is C type-safe? Anyone who took system skill before and you see, is it a type-safe program? No, right? If I declare something as an integer, can I use it as a long integer? Can I use a character as an int? The answer is yes, right? You can kind of like convert this data based on the representation, and in C, it would give you warnings like, hey, you do that conversion, make sure it's safe, right? Because the compiler is actually smart enough to say, hey, something is wrong here. As in, like, if you intentionally do it, it's fine, but we're giving you a warning anyway because you do that conversion, right? But then why should we use C? So what's the one thing that's always almost always true about C? What are a couple of benefits of using C? All right, so I believe that you all been using Python and Java before, right? You can play with memory. That's like one of the benefit here, right? C is easily compilable. That's another great benefit of C language, right? There are many ship that support running code in C, right? The other really good benefit is performance, right? Performance. In many instances of a software, I can call performance is king. The performance is king. I'm gonna give you one example that happened right now, right? You all know about this thing called MoProm, right? That is a system that kind of tracks who has been vaccinated. You all heard about it for sure, right? I believe that. Have you heard about their claim that, hey, it's performed well? Anyone kind of remember what's the number that they quote on how many transactions they can do in 1 second? Anyone remember? It's from the news. So if you do not remember, they claim that they can handle 20,000 transactions per second. Anyone want to get, is that a high number or a low number? Let's take a guess, actually. Is 20,000 transactions per second high or low? I can tell you from a system point of view, that's trash. That's how bad it is, actually. You can just probably hook up like garbage computer and make sure you can somehow make sure they run in parallel and make sure they can handle that many transactions per second. 1 second is really long. 1 second is really long. If you have a 3 GHz processor, in one clock cycle, this is simple division. In one clock cycle, how long does it take per clock cycle? with a let's say 3.3 gigahertz processor. How many cycles if I'm gonna wait 1 nanosecond, how many cycles? You do 1 divided by 0.33. What's that? So what was 1 over 0.33? Basically that's about 3 nanosecond, three cycles, right, per nanosecond. And that's nanosecond. So if you convert nanosecond to 1 second, how many clock cycles you actually be able to proceed? Actually, I don't know how you get millions. But if you do the multiplication, right? 1 nanosecond is 10 to the negative 9, and you are capable of running 3 cycles. So in 1 second, you are able to run 3 multiplied by 10 to the 9 cycle. Most of the time, that's about 3 multiplied by 10 to the 9 addition. If you look at accessing data in memory, that's about, I would say, in the worst case, 10 to the 7, 10 million. 10 million memory accesses per one CPU. I don't know what the heck did they do that they can only squeeze out 20K transaction per second. That's why I say it's a really, 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 really bad number, right? And I don't want to make any educated guess, but you can probably figure out, right? If you have a system that's capable of only handling 20,000 transaction per second, and you want to deploy it for the entire country, because basically once you get vaccinated, the doctor, right, who give you the shots, right, have to update your profile in that system saying, hey, you got vaccinated, and when is the next vaccination time, which means that you have to actually perform some transaction. Imagine if you have to open every single hospital in the country and support that at the same time. Will that be enough? Let me ask you this simple question. Will that be good enough? That's certainly not good enough, right? And one of the reasons that I feel this my gut feeling, feel free to prove me wrong, is that they might have to close down that thing so that you can't schedule your own, right, your own vaccination shots, because they don't want the user side transaction on top of the hospital side transaction as well, because you cannot really handle that. In the past year, I've seen so many systems in Thailand that are failing the throughput test. Remember those like Raushana, whatever Shana thing that the government came up with, and somehow they fail all the time whenever there's a burst of transactions? Because I can likely tell you, when you're coding something, right? How often? Let me ask you this. Let me ask you an honest question. Whenever you work on an assignment for any class, when did you actually consider about performance? Hey, I want to make it fast. Or do you want to make sure it works first? Which one do you care more? Do you want to make sure your program works? Yeah. So that's actually a great answer, right? Because in all honestly, the most important thing when you need to program certain stuff, right, is to make sure they work. That's like the king. That's a true king that I should put it, right? But when you design something and you want to launch it for the public user, right? You need to provide certain performance guarantee. Otherwise, when you have to make sure it can support the million of users, many many startup company have a product that went down, right? Anyone remember the BitCup platform that they have to kind of close down for weeks? Do you remember that? or not. Yeah, so performance is important, guys. So hopefully this real life example, right? This real life example give you good enough reason to actually, first of all, make sure your program works. That's the most important thing. But make sure you leave the room and design it such that you can implement something that perform well as well, on top of making things working, right? New issue like performance gonna be a big thing going forward. Issues like energy efficiency is gonna be a big thing going forward if you have to work on devices with limited memory. No, not limited battery, right? Things like these can performance and energy efficiency is gonna be important going forward. And not many classes in computer science are gonna give you stress about it, right? This class is one of them that I'm gonna stress about performance because it's so important. It's so important. If you want to go work in a top tech company like Google, Amazon, Facebook, uh, I don't know, Apple, right? They all care about performance. They want to make sure, say, your iPhone performed really well, right? So you better be able to do that. Performance differ across languages. Anyone here heard a joke about Python being slow? Yes, no? It's actually true, right? Uh, some of the well, one of the reason is when you actually run something, at the end of the day, this is the only language your computer understand. Assembly code, right? Everyone here heard about assembly, right? You don't have to know what it is, but you heard about assembly, right? That's the language. That's the only language your computer actually understand. And your language that you're writing, Python, Java, Rust, C, every languages here, translate your program into assembly code, right? And actually, let me tell you kind of like one of the possible reason, right, that Python can be slow is Python is an interpreter, right? Basically, you write online, you will when you run it, get compiled and run, right? That means that when you actually run that piece of code, right, it get convert during runtime to some assembly code, right? It's almost like a scripting languages, right? And there are actually quite a large body of work on how to make sure this process is faster. If you're interested, let me know. But right now, it's out of the scope of this class, right? And we are not even touching about how hardware can be different as well. Everyone heard about PyTorch and TensorFlow before? So if you heard about PyTorch and TensorFlow, you might have realized that you can run things on a GPU. And by the way, if you want to do a project relating to, say, training or inference, like trying to detect if this is a cat or a dog on a GPU, let me know, right? There's quite a lot of open source software that you can explore and run, right? That can be a totally valid reason for you to explore for your project for this class, right? Making sure you have program running on the GPU, making sure you can have a training benchmark or inference benchmark that allow some certain amount of deep learning without relying on TensorFlow or PyTorch, right? Uh, or even like those like open source, like not open source, but like the public cloud training platform that you're given. That's even worse. But if you're interested in this area, let me know for your project, right? It's totally valid project to do. But we haven't even touched how hardware can be very different. If you're curious about it, I'm gonna cover this in like a more like an advanced intermediate version of computer architecture. You learn exactly how GPU works. I am let me do the humble brag, right? I'm one of the only few people in Asia who knows a lot about the GPU because that's my thesis. my thesis is on about like how to design a GPU that are faster, and I've been working with top industry on this particular topic before. So if you're curious, let me know. But let's compare performance. Let's actually motivate you to like, hey, let's buy this argument that I want something to run fast, right? Anyone playing a game and you want your game to run at least like smoothly, where you can put like a maximum graphic setting and it run. And I bet everyone wants that, including myself, right? I don't want to buy a new GPU every generation it comes out, right? I don't have that much money. In fact, I'm so broke right now because of my scholarship contract. I owe the government so much money, and my salary is so bad. So I can't afford to buy so many GPU to play games. So I can rely on games that are good at optimizing their graphics pipeline, right? So let's compare performance. Let's assume you have a program that check if a string only consists of white space. Can someone tell me what is a white space? What is this thing? We just want to make sure we are on the same page. So I want to ask like, what's the white space? Yeah, it's like the space bar, enter, tab, anything that is just white space, right? A character that's just white on your page. So let's write that program in Ruby. Ruby is like one of the ancient scripting languages. This is actually popular before the world of Python. And I'm glad, I'm glad that Python took over, because if you look at that syntax, sometimes it can be hard to understand. But basically, this whole syntax is what it does is it detects the white space, right? So you can run that on Ruby. And similar to Python, anyone want to take a guess of like what's the downside of Ruby? Similar to Python? They are actually somewhat slow, right? They are somewhat slow. Yeah, it's being interpreted and they are somewhat slow. So you can run like about 1 million of these per second. 1 million, right? Checking if things are in space, right? So this is your throughput running on Ruby, right? So let's write this in C, right? So I have a link code here in C. If you are interested, you have the slides, but on that code basically is like an optimization of how to do um, detecting white space in C, right? And this is done, I remember correctly, this is basically done almost in parallel, somewhat, right? And you can run this 11 million iteration, 10x speed up, right? This is about 10 times faster, 10 times faster. And as I said, performance is important, right? And I say one of the benefit of using C is it's fast. And over here you see, hey, 10x faster, awesome, yay, right? How about Rust? So over here, what I have is a code, right? It's a code that compute whether your string, the input, which is your input here, buff, it return oh, my bad, true or false, right? It return a boolean. And you basically what you do is you break this array of character into slice, into a character basically. And for each character, you just check if each of these character is a white space, right? So that's how you break it down. Buff.slice, get the string in the slice, and then .char will give you iterator over each character. What does iterator mean? What does iterator do, actually? Can someone tell me what is an iterator? It's kind of like almost, right? So your answer is a loop, but I would kind of improve on that definition by saying it's something that would give you iteration of that collection, right? It's almost like a loop. You go through everything that you have. And the thing is, iterator would go through them once, right? Each element would go through them once. And the rest is just to check if they are white space, right? And apparently, this is close to C performance. Actually, this is even better than the performance in C. You can get 11 million iteration of this per second, right? So hopefully with just this one example, you buy the idea of like, hey, Rust might not be too bad until you see assignment 3, where, sorry, for breaking that bubble. Rust is great for performance, but it's also kind of annoying to get things to compile. So make sure when you work on assignment 3, you give yourself some room to make sure the code compile, right? But at the end of the day, Rust is really good at running a parallel program. Another example I'm going to give you is, let's say I want to load many images from my input paths, right, to other images. And over here is the code. This is basically a serial portion of the code. What does the code do? We'll talk about this ampersand later. We'll talk about this ampersand later when we talk about the special thing called the ownership system. But the code basically do this. Path is a buffer containing the image path. Basically, this is the path to the file, right? That's the file. And you return a vector. What's a vector? Anyone here use a vector before? What does vector look almost like? Think about it as it's an array, right? But a vector and an array, there's some slight difference. In Rust, you use a vector, but basically treat of the imagine this as an array. Imagine this as an array. Yeah, similar to the one in MATLAB, right? It's a buffer that a bunch of buffer that you can store certain thing, and over here is a vector of images. So it's an array that store images basically. And inside this, right, what I do here is I map. Well, I first iterate over all the paths. So you have a bunch of image path, right? You have a bunch of location of the image files. So the first thing I do is I want to basically load the image, right? So I load the path by mapping. The input is the path. I want to load the path and collect them all, right? Basically, this collect, put the result in this resulting vector, right? So path.iterate over each path, then you load each of the path images and create and return the vector image. And right now, this code is sequential, right? This code is sequential. You do one part at a time. Why is that the case? Because we tell Rust to do one at a time. The next example is, hey, what if I want to parallelize this? I want to do multiple of them at the same time. In Rust, there's this library called Rayon, right? That what it does is Rayon. Anything inside Rayon is anything that has to do with parallel programming in Rust. Instead of iterator, you do par.iter. This is parallel iterator. Anyone want to take a guess on what's the difference between normal iterator and parallel iterator? And I'll give a hint by asking you, right? If I have a bunch of paths, can I load them all in this at the same time? What's preventing me from opening like 10 different images at the same time? Are there anything preventing me from that? Right. So question again, are there anything that prevents me from being able to load multiple paths at the same time? Or can I do it? Yeah, no, right? To be honest, yeah, your CPU core kind of limits that, but well, I mean, if you break the abstraction of you have say 4 core, 8 cores, at the end of the day, you can do all of them in parallel. So you can use parallel iterator. Parallel iterator, what it does is basically instead of iterating one at a time, it basically iterates them all in parallel. Yeah, so that's a great question. That has to be parallel. Basically, you have to make sure whatever you're trying to do here is parallelizable, right? Using parallel iterator should pair with something that you some operation that's actually parallelizable. And Rayon is a data parallel library that converts sequential execution into parallel execution. You can take a look at that link. It actually gives you different APIs that you can call to make sure you can do things in parallel, right? And Rust would do this for you, which is really, really neat, right? If you have to do the same thing in C, it can be annoying, to be honest. If you have to do that in OpenMP, which is another basically parallel construct that we're gonna learn in this class, it's gonna be less annoying than implementing in C++. But still, Rust is also really, really good candidate for this. And over here, basically, you have this path.pariter that iterate over each part in parallel, right? And we'll go into what does it mean for something to be parallelizable. That comes later. That comes later. The next thing that you have to be careful about is what we call data race. Anyone here remember our ATM example from last week? Where I have a bank account that I'm so broke, so I only can withdraw 100 baht and I'm done. Remember that example? So that's one of the example of what we call data race, right? I have the bank account. I can withdraw 100 baht because I only have that much in my bank account. But at the same time, if I have like someone stole my ATM card and try to withdraw another 100 baht, that's a data race, right? Whoever gets to the ATM first or the bank first well, basically will get to have that 100 baht. The other guy will not, right? With me so far, basically with this example, that's why we call it data rest. You have parallel process. Each process racing to modify the data because you told them to, right? With me so far, basically you have multiple modification to your data, and some of them are just reading, some of them are modifying, read and write, right? Each parallel process are trying to either read or write to the data. So that's why we call it data race. And the Rust compiler will tell you that data race. For example, if you have this code, right? And this code, basically the only difference is instead of loading the image, the other thing we want to do is to count the number of JPEG file. Basically, I have this counter called JPEG. And whenever I see the path that ends with JPEG, I'm gonna count it by 1. So basically this is incrementing JPEG, right? If you think about data res and note that this is parallel iteration, what can happen? What can happen? So let me tell you what can happen. Let's say I have processor A, processor B, right? Both of them are trying to load multiple images, right? And this is loading JPEG. It found the JPEG, right? JPEG. And let's say this is line A. This is line A where JPEG plus 1 happened. If you break down the operation of JPEG plus 1, JPEG plus equal 1. So this whole thing, what does it consist of? It basically consists of reading, right? Read what's in JPEG, perform JPEG plus 1, and then write JPEG, right? Are you with me so far? Basically, JPEG plus equal 1 consists of 3 different operations. You read what's the current value of JPEG. You add to that, then you write it back. With me so far? Yeah, we'll see. We'll see what can happen, right? If you're with me so far, this is awesome because you're gonna see what can happen now. I'm gonna call this line A1. I'm gonna call this line A2, and I'm gonna call this line A3, right? So it's A1, then A2, and then A3 with me so far. Basically, that's how you can do JPEG plus equal 1. A1, then A2, and then A3. So these means that you're gonna have to do A1, then A2, and then A3. These processors also doing the same thing, right? A1, and then A2, and then A3. So let's assume over here JPEG is 1. So over here you read 1, right? So what's JPEG plus 1? What's JPEG plus 1? So that's number 2. At line A2, did I actually write it back yet? So does JPEG, when I look at JPEG, is it 1 or is that 2? It's still 1, right? If you look at the value of JPEG, over here is 1, over here is still 1, because I'm doing the increment, it only becomes 2 at this line, right? It only becomes 2 at this line. And let's say this particular processor comes in and reads JPEG inside the A1, what's the value of JPEG at this point? It's still 1, right? It's 1. So what's this operation? It's going to make JPEG 2. And this operation will write the value of JPEG, right? And somehow, you have the initial value of JPEG to be 1. You read 2 more JPEG files. You ended up with number 2. So that's what data res is. Are you with me so far? Basically, because the read just happened to be in the middle of this 3 operations, so when you read the value of JPEG, you'd happen to get the old value. So by accident, you get a bug, right? Is it clear? Should I explain this again? So instead of the value number 3, basically it's a returning 3 for JPEG. You got 2. And that's why we call this data res, right? So 2 good things about this syntax. The word let is kind of like def in Scala. Basically, it binds a value to a variable. And this will not compile. Because the Rust compiler actually look at this line. It's like, oh no, that's a data res. So it would yell at you, that's a data res. Because of that reason. It actually will detect this. And the way out of this is you can use a lock or you can use an atomic operation. What is an atom? So let's do a side note on atomic, right? A side note. Anyone heard about atomic operation? Okay, seems like no one heard about it. It's awesome, so I can teach you about it. So, in chemistry, what's an atom? I guess what's the older definition of atom, to be honest, because right now we figure that actually even smaller things. It's some small, like, so back in the day, we understand atom as the building block of the matter, right? It's the smallest unit. It's the most basic component. You can't break them. Well, science aside, now you can break an atom, right? But if you look at the old definition of atom, you can't really break them apart. So atomic operation is basically a set of operation. For example, that thing about JPEG, right? The read JPEG. Then you do JPEG plus 1 and you write to JPEG. The way you can fix this is to make them atomic. What it means is, if I make this whole three things that happen atomic, it means I cannot happen. I enforce that these 3 things will happen if something else come in and read JPEG while I'm modifying it. It's as if this operation never happened. So it's either everything go through or nothing go through. Are you with me so far? Basically, it's either you do A1 and then A2 and then A3. If you do all these three, it works. If you somehow do A1 and then A2 and something happened, it will behave as if A1 and A2 never happened. So that's an atomic operation. And so why is this useful for the earlier example? Can someone tell me why would that be useful? So why would it be useful to guarantee is either I have A1 and A2 and then A3 or nothing happened? It's basically to prevent data rest, right? If you have an atomic operation on the variable JPEG, what will happen is you guarantee that you get to modify and write back to JPEG before someone else can read it. That's all. Right? Are you with me so far, or is there anything that you want me to explain again? Okay, so if you have questions, feel free to ask me later about the slides, but let's go into how do I read the Rust code, right? Fn define a function. For example, Fn GCD is the same thing as I'm creating a function called GCD. Anyone want to make a guess of what does MUT mean? MUT. It's mutable. Yeah, you're correct. So this means that the input here called n is mutable, and the type is what? What is anyone wants to take a guess of what U64 is? It's unsigned actually. No, actually it's not atomic. It's unsigned 64 bits, right? Basically, you use 64 bits to represent n, and it's unsigned. Yeah, just that. So this definition means that GCD take two input, both of them have to be unsigned, and I can modify both m and n. I can modify both m and n. Assert is a macro. When I have assert with the bang, assert bang will check this. It basically will check this particular argument, and it will only assert if this is false. Only assert if this is false. For example, if n is 0, if something is wrong, I cannot compute the GCD. That's why I assert, right? So basically over here, it will assert if n is 0 or m is 0. Then the loop, wow, m is not equal to 0. Let, this keyword let is kind of like def, right? I will let t equal m, then m equals n, and n equals t. Why is it okay for me to modify both m and n? Why is it okay for me to modify the value of m and n? Because we already, well, because we actually define m and n as a mutable. When I define m and n as mutable, it means that I can modify them, and then I can modify n. What if I modify t? Can I modify t? The answer is actually no, because I didn't say t is mutable. If I want to say something is mutable, I now have to put in the word mut. Let by default is immutable. So t right now is immutable, m is mutable, n is mutable, right? So note that you can have the condition check right here without the parentheses. That's okay. You can create a local variable, right? And you infer the type, right? Where initially t is gonna be you unsigned 64. And you can use like return like this. Last line is your return, right? This is similar to Java. Not Java, my bad. This is similar to Scala. It is similar to Scala. All right, with me so far? So with this in mind, I'm gonna dive deeper into the type, more like a type system and generic. But before we proceed, let's do a 5 minutes break. Is that okay? Because we've been talking about new language. So I want to make sure I keep this screen up. No, it's not parallel yet. With Rayon, you can make this parallel if you want. I guess depending on the code and whether that's parallelizable. But right now, this code is not in parallel. This is almost like a sequential C code, right? Which IDE do we use for Rust? I think I have seen a lot of people use IntelliJ before. That should work. Basically, you can have the Rust base development for IntelliJ as well. Let me double check on if my TA have any recommendation. To be honest, I want to double check with him in case he know about something better. But IntelliJ should work. IntelliJ should work. All right, so let's do a quick break. We'll meet again at around 1:10. Is that okay? So let's meet again at 1:10, and I'll pause the recording. I'll keep this screen up so that you can double check the code, right? All right, pause. All right, so let's talk about the concept called generic, which is basically define our own type, right? Here's one example. I can find a minimum of A and B, and A and B can be any type, and it returns, right? So these arrow signs means that I'm going to return the type T. This particular function means that if you have ORD, ORD means order. Why is it important that T has to be an order type? Why does it important that T has to have total ordering? So can I do a comparison if I don't have total ordering? And my cats are fighting again. So can I compare? Can I do this if A and B doesn't have a property total ordering? Total ordering is the type, the data type that has, and the answer is no. Total ordering means that I can list out elements with this type and I can sort them. It has certain ordering. For example, an integer has basically if you have an integer has total ordering because I can compare if 1 is less than 2 and is 2 less than 6 and is 6 less than 5 or not, right? And the answer to that is yes, 1 is less than 2. Yes, 2 is less than 6. And no, 5 is not 5 is not greater than 6. It means that integer has total ordering. So does that answer your question about what is total ordering? Okay, so for A and B to be having total ordering, it means that I can compare them, basically. I can compare if A is less than B, or if A is equal to B, or if A greater than B. That's the total ordering properties. That's all. I can compare. So is it less confusing or more confusing? I hope it's not more. Yeah. So basically it means I can compare. I can compare every element in that type and I will know whether things are less than, equal, or greater than. Another thing I want to make sure you can use in Rust is something that we learned in Scala, which is enumeration and sum type, right? options is available in scalar. So you can use option like this. Enum option of t can be none or sum of t. For example, I can say option of I32. Anyone want to take a guess what does I32 mean? What's that type? Integer 32 bits, right? Integer 32 bits. So this is an option where my return value can be none, because if I have a divide, like n and d is a numerator and denominator, and if your denominator is 0, it means that you divide by 0, so you return none. Otherwise, you return n over d, right? And you can do pattern matching with the keyword match, right? Match function call over here, self division. So this is basically the function call that we defined earlier. And if this results into none, you print something. Otherwise, you print something else, right? This basically, if it matched to none, it means that there's no quotient. We can't divide them. If you match to sum v, it means that, oh, okay, it's matching to value v. You divide n by d, and that result is n over d. And you can do error catching, almost like a try-catch, to be honest, using the keyword results T and E. Results T and E is basically the same as you either have an okay results T type, or an error of type E with error type E. For example, if you want to print a content of the directory, right, and return the number of entries or standard IO errors, means that you can't really print the content of this directory, sometimes because your directory input is wrong and things like that, right? You can't print it out. Here's the example, right? You use standard path. This gives you a way to access the directory, right? Standard IO result, return type, usize, unsigned, right? You have a function called list directory. I have a path right here as an input. I want to list and count over here is mutable, right? Counter is mutable. If I can read into that directory, I do a try catch right here. Try ampersand is try catch for entry or error inside this result where you are reading the directory. If you're reading directory, if you have an entry, you count by 1, right? And you can return the number of directory that you can read inside the path. Over here is how you can use it. Path new /temp, for example, there's one directory on your computer, and you list the directory, and you have that list over here. That's a function call. See the same function name, list directory. Path is your new input, which is /temp, and you count the directory inside this /temp, and you basically tell that, oh, there's total of these many files and directory. There are total of these many directory inside /temp. Or if there's nothing in there, you're gonna get an error because the count is you return none. You return error actually. You return error right here when you have try catch, right? If the try is false, you return an error. And yes, so to address your question, you can install Rust from the plugin page of IntelliJ. All right. And the other property of Rust is the memory safety, right? For those of you who was in, oh yeah, sorry. So over here, standard path here just tells you, okay, I'm gonna use the library that allow me to open a directory in my computer. Yeah, it's like C. It's like C. And the the result over here, standard IO results means that, remember our catching error using result T of E, right? And basically this means that I'm gonna return using results which can have the valid output of an error. So results of usize basically will return either the error code because there's no directory inside that path, or the number of directory inside the path. And what else? What is ampersand path? Ampersand path is your input, which is basically this /temp, right? This give you the input, which is the path into the function. Don't worry about the ampersand yet. That's the ownership system, which is something we'll cover after the exam. We'll cover this after the exam. The ampersand basically tell you who owns this variable. The only thing that can write to the path is the owner. So standard IO result is like a norm when we write the code. Oh, okay. So that depends. So over here is the IO. Basically, this error that come from results, right? This particular error would have something to do with opening a directory. Right? Opening a directory. That means that it has to do with input and output, because that basically you try to access a location in your hard drive, right? That's why you have to use standard IO, because that's where things that are related to accessing files are stored for the libraries and all the basically constructors that you can use. For example, over here, use the result, right? The type of result specific to standard IO. So that's kind of like a norm that has to do with standard IO, which is input and output, things like handling, opening files, using the input from the keyboard, the mouse, or producing output on your screen. All right. Okay, cool. So the next thing that Rust provide, and this is something that I think for those of you who take system skill before, they'll love it. So for those who take system skill before, how many of you hate malloc and segmentation fault? For those of you who take the class before, I'm sure all of you are sick of malloc and segmentation fault, right? In Rust, the way you manage memory is different. So Rust provides three promises. First of all, you are not gonna have segmentation fault because you can't dereference a null pointer. Essentially, there's no null value. You have to use either option or results, right? There's no dangling pointer as well, right? And no garbage collector as well, right? We all use the ownership system in Rust, and we'll cover that in the next lecture. But the key here is you are not gonna have the pointer that are not being assigned, like star pointer somewhere, and you doesn't have the guarantee whether you're gonna use it or not use it in the future. Rust, the way it's being designed, you can kind of tell when do you need something, or when is the last time you don't need that thing anymore, so you can get rid of it. The other really, really good side about it is it doesn't have the garbage collector, which is important to performance. This is the performance angle. How many of you use, say, a mobile phone, say play games sometime, and you realize that somehow it's randomly you run into jitter. Basically, like things would pause for like a microsecond or like a few microsecond, and you can actually see that. How many times does it happen when you use a phone? Or it can be like less than half of a second or something like that. Like basically something would pause for a little bit. Uh, so that's great. So these days garbage collection is much better. One of the main cause of those well, actually there are multiple things that can cause that, right? Depending on how you write a program. But one of the things that can cause this from happening is garbage collection. You use the memory, right? When you write a program, you use a lot of data, right? You allocate things, you define new variables. And when you no longer use it in Python or in Java, do you have to do anything with it? Let me actually ask you this. Let's say I write code in Java, right? In Java, and I say I don't need that tree anymore, that large tree structure that I allocate earlier. I don't need it. What do you have to do? You can kind of, yeah, you dump it. You just forget about it, right? What will happen is similar to how we have garbage collector in our real life, right? When we throw this garbage that we know that we are not using, someone will come in and take it away. And that's the purpose of garbage collector. It basically free up your memory. It allows you to keep running things forever. You have a phone running for days and days and days. Like, how many people have to reboot their phone every day? I don't think anyone has to do that, right? It's not likelihood you do it maybe once a month or like once a few months, right? Because there's this work, I guess, garbage collector and then many other components to make sure things run and you don't have the problem of running out of memory, right? With the ownership system, you don't have to use a garbage collector, which means that you can perform even better. There's no buffer overrun. In fact, there's no pointer arithmetics, right? So if you're in system skill, pointer arithmetics is when you do pointer plus one, pointer plus two. Array in Rust is not a pointer. When you define an array, it's an array. There's a strict boundary checking at compile time. Why is that important? Why is that important? Boundary checking back in the old day can have safety concern. For example, anyone here heard about this problem called buffer overflow? Buffer is an array. Think of buffer as an array in C language, right? It typically when you refer to buffer, it means it's a space you can store things. It's a space that you can store certain things. Buffer overflow is yeah, actually, yes, somewhat, right? It happened when you have a buffer that you declare and your input overflow that, right? And these used to back in the day, back way back, like I said, 20 years ago, you can write a buffer overflow attack and hack into someone else's computer. Anyone want to guess how? So let's say I have function one, right? That call function two. What will happen when I'm done running function two? Oh yeah, yeah. So I'm basically explaining what does buffer overflow mean and how you can attack someone else's computer back in the old day. So let's say you have function one that call function two. What will happen at the end of function two? When I finish, what do I do? You go back to function one, right? You return to that line, that function, wherever you are in function one. How do you know what lines of code that you have to return to? How do you know where do I return to? Yes, if you familiar with systems, like basically how function call works, you go back, right? Every line of code that you're running is somewhere in your memory. So you go back to that line. You go back to that line of code that you want to continue running. What if, what if I write function two so that it has a way to store inside a buffer? And I make sure that whatever I store will overwrite the return value. It actually overwrites the return value. What happened? You can jump to a totally different function call, right? You can totally jump to a different function call because you change the return value. You overwrite where the program is supposed to return. And this is basically the buffer overflow attack, right? Because I can actually write my own function inside the buffer, inside the buffer. So let's say this is my buffer, right? And the size is this. And this whole thing is my own function. And this is where the return value is. So instead of using the old return value, you make sure they point to here. What will happen if I make sure it returns to the beginning of my own function? It's actually not infinite loop. It actually basically you now hijacked this program, right? Because instead of returning to function one right here, you return, but now you return to your own hand-tuned design function that the attacker is using. So it means I can run whatever code I want to do, right? I can have a program running and it somehow run whatever code I designed them to have right now. So you can, well, there are many ways you can hack password. Uh, Buffer overflow is more like instead of running the program that the programmer designed for you, you hijack and run your own code, right? You hijack the program and it run your own code. So it's a little bit different. It's a little bit different. So if you're curious about it, you can Wikipedia buffer overflow. There are actually an articles about it, and it's actually I think neatly written. Last time I checked, this is kind of like used to be one of the lab that we are asked to do when I took one of the system class at CMU. So we would perform this buffer overflow attack and make sure it runs our own function, which is kind of fun. Uh, So here is our in-class exercise 11. And this is easy. And I don't think you have to submit, to be honest. Just install Rust and try it out. Make sure you can print hello world. That's all, right? That's all for today. Uh, the next slides will cover the ownership system. The problem is right now I have about 20 more pages of slide deck, which I'm sure there's no way for us to cover and finish it. So here's what we'll do. On Thursday, we will do a recap for the exam. And on next Tuesday, we will have the exam. Right now, my plan format would be you're gonna have around 30 hours on it. It's designed that it should take less than 3 hours. It's designed so that I can finish it within 1 hour. And you all should be able to finish within 3 hours. Pick the 3 hours time of your life during around that Tuesday so that you can pick when you want to work on it. It's open book, open everything. You can search whatever. I know that this is not the best format for exam. Let's please bear with me about this particular format until we can go back to the in-person classes. Because basically this is almost like a prolonged mini homework, right, that you have to do. But it will contain both the written part as well as the programming part. We will do a review on Thursday. So please come with questions, because if you don't come with questions, it'll be just me monologuing about the topics that you should go through. Uh, Feel free to ask me to kind of like cover certain things that you forgot already. Or if you are still stuck on certain parts of the assignment, ask me. Feel free to ask away. That's also fine, right? And it actually happened now. So I'm gonna switch over to Discord. We have about 25 minutes left, right? So in the next 25 minutes, we switch over to Discord and we do a Q&A. All right. Stop the recording and I'll make sure